Hello everyone, in this video we are following chapter F4.4 change detection from the book Cloud-Based Remote Sensing with Google Earth Engine. Previously we checked F4.5 and we are clearly not following particular order in F4 compared to F4.5. This chapter is easy and the simple attempt here is to make a two-date land cover changes land cover change maps by using image differencing and threshold-based classification. Change detection, in its definition, is to assess how the landscapes are changing by observing the difference of two images. This helps in the quantification of the changes, maybe in the forest cover. It might be in the impacts of the volcanic eruption, maybe deforestation or wildlife, or even changes in the different land cover. This gives the insights both in the spatial and temporal aspects. A minimal approach of its kind is image differencing, where the two images, pre-event and post-event, are observed to see the changes in the landscapes. The challenges are multiple. It can be the interference of any kind of noise, such as clouds, shadows, seasonal variation, or even due to the inconsistencies based on the sensor. Observations are also not meaningful for a short period of time, or the changes that have occurred in a very brief period of time, as the change detection mostly should deal with the long-term changes or the changes that are detectable. For slow occurring changes, we need the other methods such as time series analysis to observe the changes minutely. But the two-date images are easy in identifying the changes that are quickly interpretable. The process is simple. It requires the selection of the image and then some pre-processing. Then we do some data transformation, such as calculation of the vegetation index or any type of spectral index. Then we classify the different images using threshold or even supervised classification techniques. And then we evaluate the changes or the images. A simple observation of the pre-event and the post-event images are also many times meaningful to grasp the changes in the different scenes quickly. In the chapter, we are shared with a few examples of simple observations, such as we can do this by clicking two different layers of pre and post images. So these are some examples that have been given in this chapter. So we can see some changes here. So we will briefly visit the code. If you have followed all along through this channel, all the videos, so these codes are not that difficult. I can say this. So simply, we begin with the image processing. So this ensures that each pixel records the same type of measurement at the same location over time. But most necessary processes, such as image registration or radiometric and atmospheric corrections, have already been performed before ingesting that data in the Earth Engine. So we do not need to worry about that. Here we have the USGS Landsat 8 Level 2 collection to Tier 1 dataset. This has been assigned to Landsat 8. So the bands 2 to 7 are selected and renamed to the easier names. So we have different bands, and they have been renamed within this dot select. So Landsat 8 image collections have been split into two collections for different time periods, and we have filtered and sorted based on the dates and based on the cloud cover. Cloud masking and mosaicing of the image hasn't been done here, but if the area is mixed with the clouds, that can also be performed. We also have the geometry variable that has been assigned to the point, to the variable name point. And then we also have a new variable as the pre-image and post-image. So this is just the naming of those of the two image collection. And then after we have some visualization parameter here. So we have selected some bands, SWIR2, NIR, and red with the minimum and maximum value. So this is for the visual inspection. Sometimes visual inspection alone can be very useful. So false color composite using SWIR2 in the red channel, NIR in the green channel, and the red in the blue channel can be meaningful most times to observe any problems in the images. And we can also, so let's run this. So we can also play with this this opacity here. So it just makes the image transparent, opaque. So we can scroll, we can play with this. And the important one is the calculation of NBR. So this is the way to do some data transformation. So before that, image differencing is just the subtraction of the first 8 image from the second 8 image in pixel basis. Based on that application, it can be done with any spectral indices or even bands of the set of imageries. So we need to identify the correct band or index to find the correct thresholds to classify the images for meaningful results. So for instance, NDWI can be used for water-related changes, NDVI popularly for vegetation, and there is also normalized difference fraction index to monitor forest degradation. So these are some of the vegetation indices that can be applied and used, and this can be also repeated with the same codes here. So the changes to the landscape caused particularly by fires caused by fires can be examined by NBR. So it is similar to NDVI where NIR and SWIR are used, and the values similarly ranges from -1 to +1. And NBR has been found to be responsive towards the changes in the forest, precisely in the revival of the forest areas. So in earthengine, we have this built-in function that is dot normalized difference. So this function takes two different bands, and here we also see dot rename, and this has been renamed to NBR_pre and NBR_post for easy reference. Then we see the we do some transformation. That is the single date transformation. So we have the subtract function. So this is the subtract function. So we are doing some transformation here. Here we are subtracting pre-event image from the post-event image, and that has been renamed as change. And we also have some color ramp somewhere here. So here it is. This is the palette. So this is the color ramp, and the chapter names it as says it as eefabook primary path-low color ramp. So this is designed for the colorblind, and even the color deficient viewers can use this. So they are friendly for colorblind people. So the color ramp has dark blues for the lowest values, greens and oranges for the mid-range, and the pink for the highest values. So this is basically the colors for the colors for the colorblind people. So let's run this, and So NBR values are higher when vegetation is present. Areas that are um, negatively areas that are negative means that the pixels were higher in the pre-image. Let us see this first. So this is the change image. So here, um, if the areas have the negative values, that means it was higher in the pre-image than in the post-image. And the positive differences means that an area uh, area gained vegetation. So this is basically the subtraction between the two different images, and we can interpret the values based on which value was higher in which image. The other one is the classification based on the thresholding. So in manual thresholding method, we decide some optimal values for when a pixel will be considered change or no change in the image. So here a new image has been created with a constant value of 0. So this is the basis of the classification. So we reclassify the new image using the where function, where we classify lost areas as 2, where the difference image is less than or equal to the sum threshold value. We also reclassify the gain areas to 1, where the difference image is greater than or equal to the gain threshold value. So the classified image is added to the map. In the conclusion, so before the conclusion, let's see some values here. So this one is the pre-image, that is the pre-image, and then we have the post-image, and we then subtract it. So here we have some values. We see some values in the change, and then we see the final change image classified by the threshold, where we have the 1 and 2 image as the category. So in the conclusion, this image differentiating is helpful and quickly interpretable compared to the post-classification image comparison, where two classified maps are used. The differencing reduces the multiplicative errors. So in the classification process, there might be error when we classify the first image, and there will also be error when we classify the second image. So there will be multiplication of the errors. Additionally, simple applications of image differencing and threshold methods are meaningful in sometimes when we don't know many advanced methods. So if we are able to interpret this image based on the values which is which, and if we are able to classify the changes based on these gain or loss values, then this method is also very very helpful if we are not that aware of any other advanced methods. In F4.5, we saw quite quite an advanced method, because land trainer is also complex with so many variables, so many parameters, right? So that's why this is a very easy method in its kind. So I hope this was helpful. So any comments are welcome. So I would say we will keep learning. Thank you for watching.